All right, so we need to prove this trig identity. It's a pretty complex one. So what we want to do is we want to start by converting from everything to sine and cos on both sides. So I have sine x over cos x, sine x, cos x, over sine x over cos x plus sine x. And then in the top, I can cancel out these two cos. It's just multiplying and dividing. So sine times sine is sine square x. And on the bottom, I can make a common denominator here. So I'm going to multiply the top and bottom here by cos x. So I have sine x plus sine x cos x divided by a common denominator of cos x. So the same thing on this side. Let's see what happens. So I have sine x over cos x minus sine x divided by sine x over cos x sine x 1 over cos x. And then I'll do a common denominator on the top. So I'll have sine x minus sine x cos x divided by cos x. Multiply top and bottom here by cos. And on the bottom, sine times 1 is sine squared x. Cos times cos is cos squared x. Okay, so now I'll just get rid of my huge fractions and I'll turn them into division signs. So on the top, I just have this sine square x. So it's sine square x divided by sine x plus sine x cos x over cos x. And over here, it's sine x minus sine x cos x over cos x divided by sine square x over cos square x. The next thing I want to do is I want to flip my divides into multiplies. So sine square x times cos x. And over here, I can also common factor out a sine x. I'll do that in the same step. So it's going to be sine x, and I'm left with 1 plus cos x. I'll do the same thing for this one as well. I'll factor out a sine x on the top here. Now I'll flip this as well. So multiply, and now I have cos square x over sine square x. Next thing I want to do is cancel. Sine can cancel with squared. So I just have sine x cos x over 1 plus cos x. And over here, I can cancel this cos and this square, and cancel this square and this sine. So over here, I'm left with 1 minus cos x times cos x, and it's divided by sine x. Now, these are both pretty much fully simplified, and if I compare them to, they're still not very similar. But one thing I noticed is cos x and cos x are the same. So I'm not going to touch these cos x's. I'm just going to mess around with the rest of the other stuff. In this one, I have 1 plus cos x on the bottom. So I want to have 1 plus cos x on the bottom here. So the next thing I'm going to do, this little trick is going to basically solve the whole problem. I'm going to multiply the top and the bottom by 1 plus cos x. And I'm going to write this cos x at the end because remember, I'm not touching that at all. It's the same as this side. So all I'm doing is multiplying the top and bottom by 1 plus cos x. That way it's going to make the two equations a bit more similar now. Next, I'm going to expand this bracket out by FOIL. If you expand by FOIL, you'll get 1 plus cos x minus cos x minus cos squared x. So I'll have the cos x there as the same. I'll leave this bottom the exact same as well. And then what happens is I can cancel out these two middle terms. So I'm just left with 1 minus cos square x. And guess what? 1 minus cos squared x is just sine squared x and now the last step, very simple, the square and the sine just cancel and you're left with basically the exact same thing as the other side. Now you've proved that the trig identity is basically the same.